In this video for our Mach 1 review, I'm now going over the rest of the second half of the questions that focus on our factoring and solving our quadratic equations. So this is for numbers 15 to 27 on the Mach 1 review. So with these first two equations, like 15 and 16, I notice that there is no x. So notice how b is equal to 0. So when we say that there's no x, like that would be if I had x squared, let's say plus 3x plus 2. See how here you have an x term, right? That's 3x. Well, notice how in 15 there is no x term. B is equal to 0. There is also no x term here. B is equal to 0. So I'm going to go ahead and solve both of these using the square root method. So here we always add or subtract first. So I'm going to add 75 to both sides of my equation. 3x squared is equal to 75. I can't take the square root yet because x is being multiplied by 3. So now divide by 3, x squared is equal to 25. Now am I done? Is this my answer? No, because now I need to take the square root. And x is equal to positive and negative 5. So then for 16, again, we're solving for x. So now I'm going to add 52 here to both sides. So when I add 52 here, you have 112 is equal to 7x squared. Still multiplying x by 7, so now divide by 7. So when you divide, you should get 16. Then x squared is equal to 16, but of course take the square root. So now you've got x is equal to plus or minus 4. Now here we just need to factor, but again, notice how there is no x term, right? B is equal to 0. So again, B is equal to 0. Notice how we have the difference. So focus on the difference of two perfect squares. Well, I notice that right now I have a GCF, right? So always first step, GCF. I can factor out a common factor of 2. They're both even. When I divide that out, I now have 4x squared minus 25. So now you've got the difference subtracting two perfect squares because the square root of 4 is 2. The square root of 25 is 5. So here, don't forget that GCF of 2, so bring that down 2 times. So now we can find factor our difference of squares. So this is 2x plus 5, but then not 2x plus 5 again, right? 2x now minus 5. So factoring that difference of two perfect squares. Now, number 18, there is no GCF, but we do have two perfect squares here because the square root of 9 is 3 and the square root of 100 is 10. So there is no GCF, but we can go straight to those perfect squares. So this is 3x plus 10 times 3x minus 10. So now number 19, again, b is equal to 0. So I'm going to go ahead and subtract 252 here from both sides. Now I've got x squared is equal to negative 252. Now I can take the square root, but notice I'm taking the square root of a negative value, right? So it can't be negative, it has to be positive. So we're going to take out that negative 1, which means square root of negative 1 is I. So I know I need I in my final answer. So I'm going to now mark off B and D. So here, when we factor this out, or when we simplify this, the largest perfect square factor is 36. 36 times 7. Then what is the square root of 36? 6. So 6, but I, radical 7. So that's why the answer here is A. Now, number 20 is asking for how many solutions does this quadratic have? Remember, the number of solutions always focuses on the discriminant. So the discriminant is b squared minus 4 times a times c, where a, then b, then c here. So b squared, which is negative 8 squared, minus 4 times a times c. A is 5 and C is 6. So now here, remember, and focus on the calculator, but negative times a negative, negative times a negative is a positive, so 64. Minus, so when you multiply these, you get 120. So notice how we're going to get a negative discriminant. So if I have a negative discriminant, that meant we have no real, but we have two imaginary. So that's why the answer here is D. So now question 21. I notice from my answer choices, I'm going to end up by solving by factoring, but I do notice that I have my x here that needs to be distributed. So I have negative 36 is equal to x squared, right, from x times x minus 15x. Now we can solve, but again, we cannot solve until our quadratic is equal to 0. So now we need to add that 36 to both sides. Now, can I add the 36 to anything? No, there is nothing that are like terms. X squared minus 15x plus 36. Now notice how a is just 1 here, right? X squared is by itself. We can go straight to the table. What numbers multiply to get you 36, but add to get you negative 15. So notice how we're multiplying to get a positive, right? That means the signs have to both be positive or both be negative. We're adding to get a negative 15. That means they both have to be negative. So here I could look through and use answer choices if I need to, but in this case, we would have negative 12 and negative 3. Add those together to get negative 15. So now let me go back to my factoring. So x minus 12 times x minus 3 is equal to 0. Now notice how we are solving. That's equal to 0. That means x minus 12 is equal to 0, where we add the 12 to both sides. So x is equal to positive 12, and x minus 3 is equal to 0. Add 3 to both sides. You get x is also equal to positive 3. That's why the answer is D and not C. So now with question 22, again, we're solving our quadratic. And then I'm noticing from my answer choices, see how the setup looks like quadratic formula? So that means I know I'm going to need to use quadratic formula, which is x is equal to negative b plus or minus the square root of our discriminant, right? B squared minus 4 times a times c, all over 2a. So let's again focus on the discriminant, right? So b squared minus 4ac. Before we do that, again, right, just like any other time, like in 21, our equation always has to equal 0 before we start our solving. But so that means here we need to add that 5a to both sides of the equation to get this to equal 0. Now, can we add the 5 to anything? No, there's no like term, so just bring it down. Negative 8a squared plus 5a minus 3. Now we can identify our a, our b, and our c here, right? So I've got b squared, so b squared, 5 squared, minus 4 times a, which is negative 8, times c, which is negative 3 here. So now when we go through and solve, here I've got 25. So sorry, I ran out of space. So I'll go 25. Now, negative times a negative is a positive 32, but then times another negative 3 here. So I still end up with subtracting, so negative 96. So the discriminant is negative 71. That means when the discriminant was negative, that we have two imaginary. So I know I need I in my answer, which all of them offer that. However, I do have a discriminant of 71. So I know it's got to be A or B, right? Because the discriminant is that negative 71 value. So I'm going to mark off C and B. Now I'm going to continue. Here we've got negative B here. So negative B, well, what was B? 5. Then plus or minus the square root of negative 71, which again would give you I times that square root of 71 over 2 times A, which is negative 8. So negative 8 giving you that negative 16 here. So now notice really how the two negatives will still cancel out to give you that positive value. So this one is tricky, but that's why here, guys, the answer is A. So even though we had -5 here, I'll show you. So even though we had the -5 here, if I've got -5, but over that -16, the two negatives will make a positive. So that's why here we end up with A. Now, question 23. Notice we're just factoring, right? So we're not solving, we're just factoring. So no need for changing signs, setting equal to 0, nothing. Notice how our A is greater than 1. It's 3, so I can't go straight to the table. But first, can I divide by a common factor? No. So we're going to go straight to bottoms up, where this is now x squared minus 4x, but now minus 12. Now we can set up and continue our factoring. What numbers multiply to get you -12 and add to get you -4? So again, if you need to, list out the factors of -12 and then see if they add to get you -4. So in this case, you should get -6 and +2. They will add to get you -4. So x minus 6 times x plus 2. But are we done? Nope. Because remember with bottoms up, right? Whatever you multiply by, that A value. Now make sure to divide by 3. So here I've got x minus 2 times bottoms up, 3x plus 2. So that's why, guys, here the answer was A. For question 24, again, notice how our A is greater than 1, it's 4. So do we have a GCF that we can factor out? Yes, we can divide all values by 2. So here I've got 2 times 2x squared plus 7x minus 4. Now notice we have a GCF of 2, right? So I know I need to keep that on the outside and part of my answer. So using test taking strategies, I see then it's got to be B or C because of the value on the outside. So I'm going to mark off A and D for test taking strategies. But now let's continue. Notice how we can't go straight to the table, right? Because A is still greater than 1. It's a 2. So now we got to continue and do bottoms up. So x squared plus 7x, but now minus 8. Now let's set up the table. What numbers multiply to get you -8 and add to get you +7? +8 and -1. They will add to get you that +7 and multiply to get you -8. So here I've got 2 times x plus 8 times x minus 1. But again, remember, whatever you multiply by for bottoms up, so with that 2, we now need to divide by 2. So here I've got 2 times, right? Keep that 2, that GCF. X plus 4 times bottoms up, 2x minus 1. So that's why here, watching your signs, right? The answer is C. Now let's go to question 25. Notice now we are solving and the equation is already equal to 0, so we're good. But again, notice how A is greater than 1, so you can't go straight to the table. We have a GCF that we can factor out? No. So we go right into, guys, bottoms up. So x squared minus 5x minus 6. Now we can go to our table. What numbers multiply to get you -6, but add to get you -5? Not +6, -6 and +1. They'll multiply to get you -6 and add to get you -5. So here I've got x minus 6 times x plus 1 is equal to 0. Again, we're not done, right? Whatever you multiply by in bottoms up, make sure to divide by for bottoms up. So this is x, there goes my dog, x minus 3 times, here bottoms up, 2x plus 1, oh goodness gracious, is equal to 0. Now notice we're solving and this is equal to 0. Make sure to change the signs, right? So here I've got x minus 3 is equal to 0, which gives you x is equal to +3 here because you have to add 3 to both sides. Then here you have 2x plus 1 is equal to 0. Subtract 1 both sides. So here I've got 2x is equal to -1 divided by 2. So that's why you get positive 3 and negative 1/2. Oh, my silly dog. So now question 26. Again, we are solving and it's already equal to 0, so we're good on that part. But again, notice how a is greater than 1. It's a 5. So do we have a common factor that we can factor out? Yes, I can divide all three values by 5. So let's go ahead and take care of that GCF. So 5 times x squared minus 3x minus 10 is equal to 0. Now notice by factoring out our 5, that GCF, we're down to 1. So you can go to the table. What numbers multiply to get you the last, so negative 10, and add to get you negative 3. And those two factors are negative 5 and positive 2. So again, when you add them, you do get negative 3. So I'm going to keep my GCF, right? That 5 times. So now x minus 5 times x plus 2 is equal to 0. Now, notice here we have 5. What happens to that 5? Well, it just goes away, right? Because will 5 ever equal 0? No. That's why our 5, that GCF, just goes away. But we are left with x minus 5 times x plus 2. So x is equal to positive 5 and negative 2. And so with our last question here, there's a couple of ways of saying how could we go about solving this problem. Well, notice here how a is just 1, right? It's just x squared. But could we come up with factors that multiply to get us 13 and add to get us negative 6? Well, no, because the only numbers that multiply to get you 13 are 13 and 1. They will never add to get you negative 6. We can't solve by factoring. So then what are we going to do here, right? Well, I notice now looking at my answer choices. Notice the format, right? How it's plus or minus a radical or even an imaginary part, right? How we have our real part and then plus or minus an imaginary or radical. So this means, again, we're going to use quadratic formula. So again, x is equal to, again, negative b plus or minus the square root of our discriminant, b squared minus 4 times a times c, all over 2 times a. Let's again focus just on the discriminant. Let's see what goes inside of our radical. Here's your a, b, and c. So again, here I've got b squared or negative 6 squared minus 4 times a, which is 1, times c, which is 13. Now I've got 36, that's positive 36, minus 42. So that, oh, no, I'm sorry, not 42. Oh my goodness gracious. Let me redo that. That's not 42, I apologize. That's going to give you negative 52, if I'm not mistaken. So now I've got to subtract, and here I end up with negative 16. So notice how with negative 16, we end up needing, because the discriminant's a negative, right? That means we're going to have no real or two imaginary. So we do need I in our answer. So I'm going to go ahead and just mark off B. Now I'm going to go ahead and continue. So we've got here x is equal to negative b, right? Negative b. Well, what is your b? Negative 6. So I've got negative, but negative 6 plus or minus the square root of negative 16 over 2 times a, or 2 times 1. Now let's continue our simplifying. Notice how two negatives together, so two negatives make a positive. So this is 6 plus or minus. Now, notice how this is a square root of a negative 16, which is the same as taking that apart, right? So that's 16 and negative 1. There's your I from square root of negative 1. But what is the square root of 16? 4. So this is 4i, because here you get 4, and from the square root of negative 1 is I, over 2 times 1, which is 2. Then notice here, I can divide and still simplify because both of these values can be divided by 2. So 6 divided by 2 here is 3. And then plus or minus 4 divided by 2 is 2i. So that's why here, guys, the answer is D.